Hi, I'm Priyavashni, Assistant Professor, Department of Computer Science from Dr. SNS Rajalakshmi College of Arts and Science. So today I'm going to present the topic forward pass and then backward pass techniques, which is an important concept in project management and the critical path method, that is in CPM. So these techniques help project manager plan, schedule, monitor and control projects efficiently. By using the forward and then backward pass calculations, we can determine the earliest and the latest times for activities and identify the critical path of your project. So let's begin with an introduction. So introduction to the network model. A network model is a graphical representation of your project activities and their relationship. It helps us understand the sequence of activity dependencies between tasks, estimated project completion time. So network models are widely used in project scheduling techniques such as CPM, critical path method, and then PERT, program evaluation and review technique. So the main objective of a network model is to ensure the project activities are performed in the correct order and completed on the time. Without proper planning, delays in one activity may affect the entire project. So next is in critical path method, that is in CPM. So critical path method, commonly known as in CPM, is a project scheduling technique used to determine the shortest possible time needed to complete a project. So the primary purpose of CPM is to identify the critical activities to determine the project duration. So to manage the product schedules effectively. So your critical activity is one that cannot be delayed without affecting the overall project completion date. So if any activity on the critical path gets delayed, the whole project will also be delayed. Therefore, CPM helps managers focus their attention on the most important activities. Next is in features of CPM. So the main feature of CPM or activity precedent analysis, CPM studies the sequence and then dependencies among activities. So project duration calculation, it determines how long the project will take. Critical path identification, it identifies the longest path in the network. Float analysis, CPM calculate various types of float such as total float, free float and path float. These values indicate schedule flexibility. So activity with a zero float belong to the critical path. Next is an CPM analysis process. So the CPM process starts with creating a breakdown structures or WBS. WBS divides a project into smaller activities. So the process involves listing all the activities, defining their durations, identify dependencies, drawing the network diagram, performing the forward pass, performing the backward pass, identify the critical path. Those systematic approaches helps to effective project planning. Next is a two-pass analysis. Two-pass analysis is the heart of CPM. It consists of forward pass, calculate the earliest possible start and finish times. Backward pass, calculate the latest possible start and finish times. These calculations helps us determine four important values. Earliest start is an ES. EF means the earliest finish. LS is the latest start. LF is the latest finish. So these values are used to identify float and then critical activities. Next is a forward pass definition. So the forward pass is scheduling technique used to calculate the earliest possible time an activity can start and finish. It begins at the start node and moves toward to the end node. So the main objective is to determine earliest start time and earliest finish time. Forward pass answer the questions. Okay, so what is the earliest time this project can be completed? This helps managers estimate the minimum project duration. Next, steps in forward pass. So the steps involved in forward pass are step 1, start from the first activity. Step 2, as in ES is equal to 0 for the start activity. Step 3, calculate the EF using the formula EF is equal to ES plus duration. The step 4 is move to the next activity, and then in step 5 is when multiple paths meet, choose the largest EF values. This ensures that all predecessors activities are completed before the next activity begins. Forward pass example data. Let's consider the following activity. Activity duration 1 to 8 is duration 8. 1 to 3 is an 4, 2 4 is 10, 2 5 is 2, 3 4 is 5, 4 to 5 is 3. This duration represents the time required to complete each activity. Using these values, we can perform the forward pass calculations. Network diagram activity flow. This diagram shows the flow of activities. The arrows represents activities and the number represent the durations. So we begin from node 1 and move toward node 5 using forward pass calculations. Node 1 starts at a time 0. Activity 1 to 2 means ES is equal to 0. EF is equal to 0 plus 8 is equal to 8. Activity that's after coming the 1 2 3. Similarly, calculation continue until reaching the final node. The largest completion time